My artifact is a vacuum-sealed deuterium gas arc lamp used for providing certain wavelengths of light for spectrographic analysis, mainly of organic chemical compounds. I believe it was made in the 1980s by Sylvania, the lighting company, under contract from Bausch& Lomb, the optics and scientific instrument company, in order to supply their new series of Spectronic 2000 UV-Vis spectrophotometers with spectral lamps. Although, due to an absence of direct patent information for my exact model of lamp, it is hard to determine much other than circumstantial dating evidence relating to older patents for a previous model of lamp that Sylvania had filed for. The lamp itself seems to be in good shape, and it's most likely still airtight and functional. There are some scuffs on the printed markings on the outside that during my research process led to some major misidentification of the manufacturer as Bausch & Lomb rather than Sylvania, which ended up with some research going in the wrong direction initially. The UV invisible light spectrometers that this lamp may have originally been installed in were the first mass-produced model of its type in the 80s, the picture on the right, to be controlled through a microchip electronic board. As such, it could possibly be considered one of the first forerunners in the black boxing of scientific technology that we've previously talked about in our seminars. It replaced the previous Bausch & Lomb model of spectrophotometer on the left from the 50s that was significantly less advanced and accurate, given it had an analog needle display, which assumedly would require the operator to have more skill and outside computing knowledge and mathematical model knowledge to interpret it, rather than being shown to you on a liquid crystal display that the newer model from the 80s that would have contained my artifact, maybe. So over time, assumedly for this lamp to have been separated from its unit, it must have been either replaced or salvaged in laboratory clearouts of the organic chemistry department at U of T, and then must have sat on a shelf for quite a while before being acquired by your collections department in 2018. When looking into the history of the parent company, Bausch & Lomb, in order to find out their production history of their spectrophotometers, I discovered a very interesting document from around 1908. There was a published journal detailing the problems that the company have had in negotiating with its workers' union about pension payments, and how said union was angry with the company that the company had profits enough to send lavish gifts to secure new clients in Japan for its optics business. I found this extremely intriguing, given that it was indicative of the atmosphere for the working class around the world at that time, given the rise of unionization in the Western countries, and the Russian Revolution was only 10 years away. There was also a promotional book that I found from 1941 that was illustrated in a whimsical children's fairy tale style, as seen on the slide. The book detailed the founding myth or story of the company itself, of Bausch & Lomb, the men in around 1870-ish, and had descriptions and images of its current operations in 1941 and its manufacturing processes. And the images are also on the slide. With the latter, as in the current operations and manufacturing processes detailed, being a window into 40s wartime America, as the language was flowery, and you could almost feel the essence of the hopeful American dream oozing from the words and in the industrial pictures. Turning my attention to the history of the arc lamp technology introduced me to some intriguing stories of innovation and societal development. Arc lamp technology originated, as many modern technological concepts did, in the parlours of the rich gentry experimenting in the 1800s. The first carbon arc lamp was constructed by Sir Humphrey Davy in around 1812. He was an accomplished chemist and is credited with the discovery of electrolysis, resulting in the discovery of many elements such as potassium. And he was a founding father, you could say, in the field of electrochemistry. On a more fun note, he was heavily involved in the experimentation of inhaling gases to see what happened, and is credited with nicknaming nitrous oxide laughing gas because he couldn't stop laughing. In 1886, even the mind of Nikola Tesla turned its attention to the development of the arc lamp for lighting, which obviously shows its importance with society at the time. Tesla's patent described a mechanism for the technology to improve its power efficiency and decrease the likeliness for it to extinguish itself. And as I said, I found it fairly interesting that the technology was widespread enough and popular enough in the late 1800s to attract the interest of such a famous figure to patent mechanisms related to it which were adopted widely. At and around 1900, at the turn of the century, there is a criminally unknown figure in that of Hertha Ayrton, who impacted the development of my artifacts technology heavily. She was an extremely accomplished physicist and mathematician who specialised in the study of the electric arc and in the mathematisation of fluid dynamics and studying the movement of ripples. She was an active suffragette, an extremely active suffragette, and a feminist activist for women in the STEM sciences in late Victorian Britain. Her notable work in the history of artifacts technology forced the male-dominated scientific world at the time to acknowledge her, and she became the first woman to speak before the Institute of Electrical Engineers and the Royal Society. She also, through her work with fluid dynamics and ripples, developed a fan to disperse poison gas in the trenches of World War I. I feel, having uncovered her history in my research, that she should definitely be much more well known and recognised in popular culture for her contributions towards science and the suffragette movement. Before arriving at the advanced gas absorption spectroscopy lamps that are used today, such as my artifact, the history of the arc lamp within popular use was a long one. Throughout the 1800s, after Davy's discovery, the carbon arc lamp was used as the main source of any electrically produced light. However, with the onset of the incandescent bulb, the theory of which was also pioneered by Davy, even though he didn't go on to create the first bulb, the use of arcs as everyday lighting come to an end. But with the air of the marvels of science that spread through society in the late 1800s and early 1900s, the arc lamp did not just stay as a light source. It infiltrated into professions and started becoming utilised for other ingenious practices. For example, in a medical electrics reference book for students that I found from 1909, it was the use and usefulness of an arc lamp emitting large amounts of UV light was recommended to treat various skin conditions. However, looking at other chapters within the same book brings into question the validity of their claims, given that there is a chapter on the usefulness of machines similar to a Van de Graaff generator in soothing the physiology of patients with static electricity. There is a truth to the therapeutic effect of current passing through muscle. However, waving a statically charged wand over someone certainly sounds like quackery. I find it intriguing how the fringe treatments were even taught to medical students and recommended to be used, without any concrete proof. The current main use of the arc lamp technology is used within scientific analysis. For example, my artifact my artifact was made to ionize deuterium gas, which it is vacuum sealed inside it, to give off specific wavelengths of ultraviolet and visible light. That, when passed through a sample of unknown organic chemical, gives off a unique fingerprint spectra, allowing its identification. And other modern instances of the same application of the gas dispersion arc lamp is that of calibrating spectra taken from distant stars and galaxies and celestial objects to work out the composition. Like seeing the spectra of an exoplanet's atmosphere that may be 30,000 light years away.